Okay, I was wondering what life would be like if I could talk to the most intelligent, most capable guys when it came to compressor. And then I go, wait a minute, I got friends that are really smart when it comes to compressors. Guess what, guys? I got another one for you. This is from the NTEA show in Indianapolis, 2023, and I'm going to introduce my good friends. It's Chris and Chris. It is kind of funny, but I'm going to let them introduce themselves. This is Chris and Chris, and they are joining me today from VMAC. All right, hang tight. Go ahead and get started. Hey, Chris.
I am the first Chris. I am Chris Moyse. I am an engineer for VMAC. I work on our vehicle integrated compressor products. I'm going to let the other Chris introduce himself real quick here.
Hello, I'm Chris Lamb. I'm in sales and application engineering for VMAC air compressors.
All right, so what we were wondering when I came up with this idea to get my friends from VMAC to join us was what exactly makes a good compressor on a field service truck? I mean, if you talk to the sales guys like me, we'll tell you it's the latest and greatest and best, and it's going to do a great thing. But I was lucky enough to round up one of the top sales engineers from VMAC. Now, VMAC is based in Canada, am I right?
That's correct. We're based on the west coast of Canada, just a little ways west of Vancouver, a little ways north of Seattle. That's where we're at.
Well, they are a fantastic company. I've worked with them for many, many years. But what I wanted to do today is I wanted to get into some nitty-gritty. And could you help me understand what exactly does VMAC produce when it comes to compressors for field service trucks?
We've got a few different products, both in the self-driven compressor segment and more vehicle integrated products, which for us is our underhood compressors, which are belt driven off the engine. And then we also have our direct transmission mounted products, which are mounted off the PTO directly. So that kind of is our two main segments. We've also got some multifunction power systems that do AC, DC power, hydraulic power takeoff capability as well. And that comprises our main offerings as well as our hydraulic driven products for the work truck market.
Okay, well, I appreciate that. Now, one of the things that I was wondering when it came to your compressors is I found out about VMAC, I think it was probably 25 years ago, when you guys came out with the underhood, I think it was a V870 or something like that. It was an underhood compressor, and it was tied to the Ford 6.0, if I remember correctly. And at the time, that was a game changer when that was first introduced, because I was at a dealership at the time running a fleet department, and I just thought that was the latest and greatest and coolest thing I'd ever seen. And that was my first introduction to VMAC. Since then, I now work for one of the big body companies myself, and so I deal with you guys on a regular basis, so I've gotten to know you a lot differently. But can we talk a little bit about that particular application, and is it still viable as a solution for a service truck?
Yeah, the underhood product is really kind of where VMAC got its start. We started out as a company that primarily focused on making brackets back in the, let's say, early 90s. And as the engine bays of trucks got more and more filled with other components, we realized that we needed to have an extremely compact way of making really big amounts of air. So our 70 CFM product is kind of the core of that philosophy. And a rotary screw compressor is at its core an extremely small package item, which can produce 100% duty cycle air whenever you need it. So yeah, that has been kind of our investment in manufacturing these things, and not only integrating them with the trucks, but manufacturing them right from raw materials. And it gives us a high degree of control over keeping those things viable as the trucks get more and more complex, because we have full control over what the shape is, what the mounting interfaces are. So for us, it's not something you can just pick one up off the shelf from another supplier. It's really something that we develop ourselves, and that's why we're able to keep it relevant, even with some of the more complex trucks that we see today.
Now, being a naysayer, obviously my concern for the end user is reliability. Now that we've had this product in some shape, form, or fashion on the street for well over 20 years, what has been your actual results in terms of warranty, reliability? What's the feedback been on that product?
Well, it's actually very good. We have our set of components that we are able to graft onto different vehicles, and we've got a lot of experience doing that work and engineering those specific kits for each application. So what we've been able to do over the years is really get the core components up to an extremely good standard, and also develop that knowledge that enables us to approach a new design with a lot of experience that makes it a lot easier to achieve a successful result. The end goal for us, if somebody opens up the hood of a truck with our product on it, if they can't figure out what component came from us, that's a victory for our design team, because that means we are designing stuff that looks like OEM factory equipment, and that's our goal.
Now, back in the day, what used to happen is you take it into the Ford dealer, they look under the hood and see a VMAC, they'd scream, say, "I'm sorry, we can't do it. It's their problem." Did you experience that, and how did you deal with it?
There's always situations where people might try and, say, "Oh, there's some other system on here. That's clearly what's causing an issue," or, try and play that card. And it happens occasionally, but we're getting a lot better, and we do work closely with the OEMs when we're doing these things. So, we need to make sure that we're not compromising, first of all, the safety of the vehicle in any way. And that is our primary goal. But the next one is, are these things as minimal impact as possible in terms of, the serviceability and the familiarity of the truck once somebody opens it up to do some work on it.
Now, not everybody needs 70 CFM of air at 175 PSI. Do you guys have other offerings that are under hood?
Yeah, our underhood product line ranges right down, from 40 CFM, 70 CFM, 150 CFM, and our DTM products are really anywhere from, 40 to 185 CFM now.
So for us lay people, the guys that aren't hanging with you and me all day long, can you help me understand what DTM refers to?
DTM is what we refer to as our direct transmission mounted air compressor product. So this is something that is designed to effectively mount on, as you would a hydraulic pump, onto the PTO. And that enables you to not make any intrusion on the underhood space of the vehicle. And if you're concerned about warranty situations, that is really the way to go. It's such a minimal impact on the truck. So that's what that refers to.
How does that product compare price-wise to the under hood system? We're getting another Chris here.
I guess I'll step in when it comes to pricing. So price changes between the DTM and underhood is normally just the cost of the PTO. So the system operates almost identically. The difference is, you got your lower install times, and then you just had to add the cost of the PTO to it, which comes with the kit.
Okay. And when it comes to compressors, for the average guy like me, all I know is it's an air compressor and it produces air. Obviously, training says I'm supposed to know the difference between a reciprocating compressor and a screw compressor. But since you guys are kind of one of the leaders in the industry when it comes to the screw compressor, can you tell me a little bit about, or tell all these guys a little bit about the VMAC approach to screw compressors and how it may or may not differ from other OEMs?
Sure, I can start out on that one. So the industry as a standard originally was built around reciprocating compressors. Everything was reciprocating. It's a piston-driven unit. They work for a lot of years. Unfortunately, the technology that has changed over the last 30 to 40 years, especially, has allowed us to be more efficient. So your reciprocating compressors are very heavy, very loud, very low duty cycle. And by duty cycle, I mean the amount of time it can be ran and before it has to be shut off. It needs to be off about the same amount of time. For rotary screws, 100% continuous duty. So VMAC took the approach that we're going to go a bit further. Not only are we 100% continuous duty, we manufacture out of lightweight aluminum components, which helps dissipate heat faster. It helps burn off moisture, which is just a byproduct of compressed air in general. So it's the reason why we're able to offer lifetime warranties on our air ends and everything that we do. The rotor screw is the way to go. I mean, air on demand, don't have to have an air tank for it. it's a phenomenal product, and it'll be there for long hours.
Now, what I've heard, every once in a while I'll have a customer and he'll say, yeah, I don't want one of them screw compressors, the oil turns milky and all this other kind of stuff. So can you describe the requirements of an end user when they're using a screw compressor? Because I assume it's a little different than what they would have to do if they're running a reciprocating compressor.
That's actually a good question, and actually it comes up quite often. I'm actually glad you brought that up. So it is different. Rotary screws are designed to be used, and by that I mean they're designed to be ran, and they're designed to be ran as hard as you want them to in theory. Reciprocating compressors don't produce as much moisture because they get so hot, but rotary screws need to run to burn that moisture off. I mean, we as a company suggest it run weekly, if it can, at least monthly to burn that off. Now it takes, you got to get the oil temperature up a little bit, but I'd say most people if they could use it 15 minutes at a time, they're in good shape as far as burning the moisture off the oil. Moisture in the oil it happens with compressors. You're going to get moisture. It's not whether it's my brand or somebody else's. It's always going to be that way. It's always going to be there. The end user just needs to be aware that he needs to use the product. It needs to not run for 5 minutes or run for 2 minutes. It needs to be turned on and used for 15 minutes at a time if possible.
So as a rule, if it goes through that warming phase and it gets to nominal temperature, is that sufficient?
It is sufficient. VMAC has done a great job engineering a way to the warm-up cycle is controlled. I like to see it go a little further, but ultimately, if it gets through the warm-up cycle, it's already reached a stable temperature in which the moisture is started to come off of it.
Now, you mentioned the lifetime warranty on the end. What was it called?
An air end.
An air end. What exactly is an air end, and why is that important?
So an air end is just another word for an air pump. So that's the actual component that builds the air in the system. Why it's important is, one, that's 80% of the cost of an air compressor system is that component. Okay, that's what makes up the most expensive part in there.
Now, if you have a unit that has 100% duty cycle and there's no lag time for the amount of air that it can produce, it produces its maximum CFM once it's reached its nominal temperature, does it also need air storage? Is that also part of the package? Is that a requirement?
It's not a requirement. Air storage is always a benefit. Okay, the more air that you can put into a tank, it lowers cycle times. It just overall it helps. But it's not a requirement in rotary screw. You can very easily do away without it.
Okay. All right. So the next topic we want to talk about is idle mitigation on these multifunction units. Now, Chris Numero Uno, he was kind enough to kind of touch on that a little bit, but let's go a little deeper and talk a little bit about VMAC's approach to the multifunction. So before you start, let me just tell you what's going on. So our typical member is looking at $5 a gallon for diesel fuel. And they're typically running these trucks most of the day. And then they have a need for air, and we're trying to encourage them to use alternatives, okay? And the alternatives that everybody came up with were these multifunction auxiliary power units. Typically, we're running on these Kubota diesels, and that was going to be the solution to the problem. Okay, what I want to know specifically is, what did you guys do? What did you do better, and where are some areas of improvement for that type of product?
Yeah, well, that's a great point. I mean, when you're running the main engine of your vehicle, you are burning diesel fuel. Like, there's no arguing there. So being able to transfer that onto a smaller power unit that's more, directly sized for the auxiliary functions that you need is a great option. What we've done is, we're running off that Kubota diesel. We also have a couple other engine options that we've brought in. Just in terms of if customers have a preference, we have Caterpillar diesel and then Honda gas as well. So, being able to be flexible with the choice of fuel and also just, running things on that smaller engine is a great option.
Now, am I going to utilize less fuel? If I go with the Kubota diesel, if my member uses the Kubota diesel, how are they receiving the savings specifically? Are they burning less fuel per hour, or is it from the fact that they're not running the bigger truck, so they're not putting as much wear and tear on the after treatment? of the truck, so they're not going through DEF issues and DPF issues. Where is the real savings coming from?
Right, so the savings is multifold in these systems, and yes, they're going to save on diesel fuel alone, and because like Chris one said, is it reduces the amount of fuel that you're actually, because you're running a lot smaller engine. However, the savings that really add up in the multifunction system are the ones that we don't always do a good job of tracking, and that's the amount of hours that's put on a chassis, which is determined, that's what your warranty and service rate is now. Idle time has always been very difficult. When you have an issue and you take it to the manufacturer for service, and it's got 4,000 hours on it and 10,000 miles, it's not under warranty no more. It's just been sitting there idling. So that's a major concern. So that's the one. And with the new emission systems that every chassis is required to have, we're staying below that Tier 4 requirement. We don't have that on the APU units. That's where your true savings come in, because the amount of money that is tied up in fixing or repairing emission systems is substantial.
How did VMAC approach the problem in your multifunction? Is it one size fits all, or is it compartmentalized? Are you able to modify these multifunction units to meet the needs of an end user? How did you guys go about that?
So it's a good question. So we took a different approach when we originally designed the multifunction, and the multifunction was designed in a modular platform. And what we mean is kind of like going to the cafeteria and you're picking out what you want. If you want these 3 functions, you get those 3 functions. You want all 6, you can have 6. That's the approach that we took at it, and it's not there's no such thing as a one size fits all. We've all learned in this industry. We like to give customers the option and tell them, hey, if you don't want air, or if you don't want air and you don't want hydraulics, fine. If you don't want generator, or you do, great. It's an option there. We build it to suit the customer more than anything.
How did you guys approach welding?
Welding's a little bit harder to talk about because there's so many good welding machines out there. We approach welding a little bit different. We wanted a unit that was comparable to what was offered by the big name brands, okay? We wanted to be able to control the amperage. We wanted to be able to control the arc and everything that we have inside of a compact unit. So for that, we had to go and have one design that worked for that application. And we've done a good job. This unit is a very good welder. It's only rated for around 250 amps. So, you're not building this machine for a full-time welder, but it is built for the standard service truck.
So the key measurement that I hear when I'm working with an end user is, can I arc gouge? Can I run the air compressor and the welder at the same time? How did your unit handle that?
That's good, because arc gouging is not talked about very often amongst APU units, and what we found is we were one of the few that could do that. And so the way VMAC designs its control system is we control the cycling of the air compressor when load reaches too much. So let's say, for example, they're running arc gouge system and the electric requirement is substantially higher, it would cycle the compressor on and off. To do the arc gouging successfully, from our testing, it requires a 20-gallon air tank. We have to have that storage just because arc gouging can drain a lot of amps and it takes a lot of horsepower. And so with that extra air storage, it allows our control system to cycle the compressor on and off based on when it's needed.
Okay, well, that's really cool. Now, the one other area that you guys kind of, I think, do a pretty good job on is your smaller gas-driven compressors. So let's talk about that. How are you guys approaching that? Why would a guy want to consider a VMAC when a Honda or the Ingersoll Rand or one of the other brands has been doing the job for them all day long, or they can buy one at their local Northern Tool? How do you guys, talk to me a little bit about that?
So yeah, there is more competition out there with those gas-powered air compressors than you could ever shake a stick at, and some are really good units. So most of the industry is very common with the Ingersoll Rand, the 2475s, the T30, whatever you used to use on the back of the truck. The benefit over the VMAC, the 30 CFM gas-powered unit in particular, is 250 pounds lighter than one of the closest competition. And the most common unit is almost 250 pounds heavier. That's what you're looking at. Being able to take that space back, not just space, but being able to take that weight back for your application is huge in today's market when everything is built around weight. Everything we do. If you take 250 pounds out of a truck, that's 250 pounds of capacity you have to do something else with. On top of that, we're going to be able to do more air in a smaller package. So same horsepower engine, we're going to be more efficient longer hours service life out of it, and it's lighter.
And if I remember correctly, you guys did a tweak. You came out with a G30 stack unit. Tell me about that. What was that all about?
So the G30 stacker was just another option offered in the G30, but the difference is there was some customers up north and in Canada, if I remember correctly, who wanted to put it inside a compartment. They wanted to be able to use it. It goes inside the compartment of the truck. It's not out in the elements. They don't have to climb in the back of the truck to use it. So they put it on a slide out, and it fits inside the front compartment. That's what it was designed for. Now it's slowly moved over into vans and other markets and stuff where they're not running the underhoods. That's where you see the stacker really the most common.
Okay. Well, the whole purpose of Service Trucks USA is to help guys run their business so their business doesn't run them. Okay, so let's wrap up our little chat today at NTEA by discussing ideas, concepts, anything you think that will help improve the daily life of an end user. What can VMAC do to help my boys and girls make more money, save more time? What can you guys do for them?
Well, obviously the salesman in me is going to tell you got to buy VMAC. It's the only thing that's going to save you the most money and most time on your hands. Ultimately, each person has to analyze that question differently, but what we as a company can do to help them is we'll develop a product that we think will help save them time, less downtime, which increases their uptime and the amount of time they can make money, and less service requirements. So ultimately, you spending less time working on your truck and letting the truck work for you. We will build an application that'll suit your needs in most cases.
Well, listen, I can't tell you guys how much I appreciate you. We've been friends for a long time, but
Yes,
this
sir.
is a little side hustle that I've been working on and I'm trying to expand. And what I'm trying to get across to all you guys that are listening today is you got an industry that cares about you. You got guys that know other guys and gals that know other gals, and all together we're going to try and give you a product and give you stuff and solutions that you guys can take to the bank. And I really appreciate Chris and Chris hanging out with me today at NTEA.
We appreciate it, buddy.
We're having a great time here at the show, and I think VMAC does a fantastic job. I think that you should give them a thought when you're looking at your service truck the next time. Just know that these guys are the real deal, and they've been really good friends of mine for a long time, and I appreciate their support. So thank you, gentlemen. I really appreciate you.
Thank you, sir. We appreciate you.
Yeah, all right.
Thank you very much.
All right. Bye, Chris. Bye, Chris.
Bye.
Subscribe right now to Service Trucks USA on your favorite platform so you'll never miss an episode. And don't forget to follow us on Facebook at Service Trucks USA. That's Service TRUX USA, where you'll get even more great content, discussions, and resources related to vocational service trucks. I look forward to getting to know each of you better. Until then, keep your fingers dirty and your nose clean. This is your guy, your man, your dude, KJ, signing off.